Good morning and welcome to another Technical Tuesday by Chipmaster. This is the 18th Technical Tuesday that we're delighted to present with you. And it's an absolute privilege for myself to be here with you again with an opportunity to impart a little bit more knowledge onto you. Today we'll be going into detail on the hatch window and how it relates to the settings within our machines and the chick quality implications of it as well. I've got the absolute pleasure of being joined by Chad Daniels today, who's the subject matter expert on Chipmaster for this. So without any further ado, hopefully hand over to Chad Daniels.
Good morning, everyone. I'm pretty excited about this particular topic. I think it's something that spend a lot of time discussing with hatcheries individually when we visit, and oftentimes we've recognized a lot more here lately the importance of communicating with machines, as we do a lot of Zoom calls and we do a lot of online team viewer sessions with hatcheries. So I hope some of you customers are out there that we've had the opportunity to do that with. To not delay it any further, let's go ahead and get started. We're going to discuss hatch window impacts and adjustments. And so kind of to begin with, from a topic standpoint, we're going to discuss what is hatch window, and then we'll discuss monitoring hatch window, and then what impacts hatch window, duration and peak. Probably some terms there you may not be familiar with at this particular time, but hopefully as we progress through the presentation, you'll gain a better understanding of what these terms are. So when we look at hatch window, it really starts when the first chicks have hatched, and we see that here, and then it ends whenever the last chicks have hatched. And so we recognize that in a hatcher machine, a lot of times in today's environments, the difference between when chicks start coming out and the time that they're finished holds several things in place for us, and there's a lot to be learned from it. When we look at that as a simple view, what you recognize here is that when the chicks hatch, the moisture from their body, the moisture that is needed in order to allow them to pip and get out of that shell, that moisture is released into the environment in the hatcher machine, which creates a natural curve in humidity. And we see that curve as this type of an example, where on the left side of the screen, the bottom number of 78 and a high of 92, that's a wet bulb range. And across the bottom of the screen, we see a time value, and essentially that's more or less 2 days. So this would represent like a 19-day transfer. The first thing that happens when we see this is that we identify this blue line as, in this particular case, as a wet bulb. And you'll notice that in the beginning, there's a slight rise, and oftentimes that occurs when the transfer process is happening, because you'll get some sanitation from your in ovo on the eggs. And so you'll immediately see a slight increase in wet bulb, but then it'll go down and it'll average to a setting. And basically it'll stay there until you see when the pipping begins, when the first chicks start to hatch. And that's when the moisture level will start to rise. The next thing we identify here is that there will be a peak pipping, and that's our highest point or our highest measurement of wet bulb reading. And then, of course, last is a dry down period leading up to pool. And so this is a simplified version of basically saying this is what we're looking for with hatch window. Hatch window is a lot of small pieces go into this, but this is the simplest way to actually illustrate where the pipping begins, peak pipping, and then that dry down period that leads up to pool. When we look at it on a graph, and this is an example of a graph that was pulled up from an incubator or a hatcher machine. When monitoring that hatch window, you recognize that there's a couple of things that I want to focus on here. One being, you see the same humidity curve, but I really want to see, when did my peak occur? And when that peak occurs, that's telling me that's the highest volume of hatching is occurring at that particular time. And I want to know when that happens, because when that happens, that tells me that I can now calculate the time period from peak to pool. And that helps me manage several things. But the second piece that I look at here as well is hatch window, or duration, essentially. And that duration tells me several things as well. So we're going to break this down a little bit today and talk about the difference between the two and what impacts both of those, and things to focus on in your hatchery that will hopefully help you manage your peak and manage your duration of your hatch window. So to start with, let's talk about monitoring hatch window. So when we break this down, the time from peak to pool helps identify chick readiness. The ideal range is somewhere between 15 to 20 hours. Less than 15 hours can produce wet chicks and unhealed navels, meaning I'm still going to have some chicks that may have not finished completely pipping, or have just completely pipped and have just come out of the shell. And so at pool, we'll see chicks like that will lose or get culled out. You know, anything over 20 hours, then we oftentimes will start to see things such as dehydration and stress. And obviously that depends on how well you manage your hatcher machines and their ability to control temperature. But that's the thing that we look for right there when we talk about that identifying peak. So incubation parameters, time and temperature, are key to managing when that peak occurs. And we'll get into that in more detail here in a little bit. The duration of hatch window is a direct indicator of temperature uniformity during incubation, along with egg pack characteristics. We'll also get into a little bit more detail with that as we go through, but identifying the duration of hatch window in your hatchery is the key to troubleshooting. So if I'm not monitoring my hatch window and I don't know when my peak occurs and I don't know the length of my duration, it makes it rather difficult to identify what could be causing the problems, or what do I need to adjust to get better. So when we talk about monitoring hatch window, there's a couple of different things to look at. One, to get started, you must have either a wet bulb probe or a relative humidity sensor in your hatcher machine. And I make that statement because what I see a lot of times today is hatcheries that have made the determination that they don't want to use humidity or mechanical humidification in their hatcher machines. And that's fine. There's not an issue with that. But as a byproduct of choosing to not spray humidity, then the decision was made to not utilize a water bottle or a wick, or replace the humidity sensor if it fails or goes bad. So in order to actually have the ability to monitor your hatch window, this is a simple requirement. You've got to have the wet bulb. So a wet bulb is more common. We see this because it's more durable. It handles extensive cleaning. A wet bulb is simply nothing more than an additional dry bulb probe that we are installing a water bottle and a wick. And therefore we're taking an actual wet bulb reading. So wet bulb comes in from the fact that that probe is now measuring the evaporation rate of water off of that wick or off of that bulb, and the temperature that is the byproduct of that is referenced as wet bulb. So as the chicks begin to hatch and higher moisture is produced, then the water will evaporate from that wick at a much slower rate, and therefore the probe will read a much higher temperature. And so that creates a really nice graph to look at. So the importance around wet bulb is that you need to choose a wick material with a medium thickness and make sure it fits on the probe well. A lot of times during hatchery visits, I see wick material that's really thin and it doesn't stay up on the probe, or it's not pushed all the way up on the probe very well. So it's important to make sure that's correct. Oftentimes too, we see that hatcheries that have a better process here, they're using either mineral-free or distilled water in their water bottles, and they're doing that because they oftentimes have a lot of hardness in their supply water at the hatchery. And over time, that hardness will just collect on the probe and then just cause either probe failure or a bad reading. So if you've got a lot of hardness in your water, make sure you do use a mineral-free or distilled water. Obviously, after each hatch, it's important to dispose of that wick, clean and disinfect the water bottle, obviously because it collects a lot of chick down. You get a lot of down in the bottle itself, and you don't want that to carry over to the next hatch as an opportunity to cross-contamination. So to calibrate, and this is important, I run across this periodically, is you simply remove the wick and calibrate as a dry bulb. So I oftentimes see situations where hatcheries try to calibrate the wet bulb in a hatcher machine as a wet bulb, and that's not what you do. So this will give you a more accurate calibration of your wet bulb. More about monitoring hatch window. Just a quick tip. You know, what we've talked about so far is having a wet bulb, but if you do have a relative humidity sensor, one of the recommendations is to use a plastic bottle to protect the probe during the cleaning. And what you'll see here is a couple of illustrations where this customer took a more or less a plastic bottle with a screw-on lid, and they attached the lid physically to the roof of the hatcher machine and inserted the relative humidity sensor down through that lid. And then during washdown procedures, they simply put the bottle in place and screw it up over the sensor. Once you get the hatcher completely cleaned and everything is done, you have to remember to remove that bottle and then use some form of a disinfecting wipe to just wipe down that relative humidity sensor. So as a quick tip, if your hatchers do have the RH sensor, to get an extended life out of them, use this water bottle to protect them during washdown. So the best way to monitor hatch window is to install a user-friendly system such as Chickmaster's Maestro software system. Obviously, Maestro is a system that Chickmaster developed years ago. We're pretty proud of it. It is a very user-friendly system. If you don't have the Maestro, you may have a type of control that won't communicate with Maestro. We'll cover that here in a second, but I feel the most important piece of really being able to monitor this is a means of having a software system so I can look at multiple hatchers in sequence and have a much better system that's more user-friendly to give me better data. So we look at a graph like this with a Maestro system, and you can pretty quickly see some of the information that we get from a hatcher machine or a hatch cycle. And we see Maestro allows a quick viewing of the wet bulb, shown here in the green. We also see the temperature profile that the hatcher machine followed. And then we also recognize that we've put up here on this particular screen a heating and the cooling function. And that kind of lets me see how well the hatcher machine managed the temperature set points and how hard it had to work to accomplish those things. So additional items include, which aren't shown on this particular graph, but with Maestro, you'll oftentimes activate damper position, blower operation, and even CO2 monitoring if you have a CO2 sensor in there. So a lot of information can be gained from a Maestro system that more or less really gives you a strong indicator of how well your hatcher machine operated, the quality of your chick, the health of your chick, and hopefully avoided stress during that. So another important note is that all of these things can be recorded here without opening the door on the hatcher machine. And I bring that to note because a lot of hatcheries today, without having the probes in place or without using water bottles and wicks, or without having a software system to enable this monitoring, I find that in order for them to determine chick readiness, they're simply going through a process of opening the hatcher, removing baskets, counting how many chicks are out in a basket, various places in the hatcher machine, in order to determine chick readiness. And that does provide some form of adequate information, but it's not near as detailed as you see with a good software system. In addition to that, you're influencing the environment in the hatcher. You're obstructing that environment, or you're oftentimes you can be disrupting it. So we know from an embryonic standpoint, when the chick is pipping and working to get out of that shell, it's a stressful time for the chick. And so if you disrupt that environment in the middle of that process, you can cause some delays. In the chicks that haven't pipped out yet, you can cause some delays in that process. So that's something to be mindful of. When we talk about monitoring, also a quick tip: if you do not currently have Maestro, we'll oftentimes see hatcheries that use check sheets hanging on a clipboard on the front of front of a hatcher machine, and someone goes around every couple or 3 hours and documents the temperature and the wet bulb and things of that nature. If you have old controls and you're not capable of communicating with Maestro, control upgrades are obviously a good step in the right direction, but you can also modify the sheet. This is a sheet that I ran across years ago at a hatchery, and I thought it was kind of interesting because they modified it so they could basically just put a little dot at where the dry bulb temperature was at that particular time, and then also put a dot where the wet bulb temperature was at that particular time. And it's kind of interesting once you see the end result is you do have a very descriptive view of what your hatch window looked like, or your humidity curve, and it basically indicates what time your chicks first started pipping, when your peak occurred, and then how long it was from your peak to pull. And so this is a way of a quick tip of being able to modify your sheets if you don't have any other means of doing this. So on to the next topic, what impacts hatch window? And the thing we've talked about so far is duration and peak. And right now I want to talk a little bit more about duration because I feel like it has a bigger impact on an indicator of machine quality and any inconsistencies during incubation. So begin with, when we refer back to this drawing, when I look at duration, I'm really trying to identify here, when did my pipping begin? And then when did I essentially near the end of the dry down period, or when chick readiness is completed during that point. So here's my duration. This is my hatch window duration. And, ideally this happens within a 20 to a 26 hour time period total. And so the shorter this duration period is a stronger indicator that you're more consistent for your incubation parameters. So what can impact duration? Obvious one is uniformity of temperature during incubation. So in multi-stage, our classic multi-stage incubators, oftentimes we see machines that have heating and cooling simultaneously. This will obviously cause an issue with uniformity of temperature. We'll see machines that are not calibrated that cause this to happen. Oftentimes a lack of split cooling or two-zone cooling, meaning that front of the machine may require cooling, which can cause cooling or overcool the rear of the machine. So you'll see the front cool, and then immediate processes, you'll see the rear of that machine cycle of heating. And so that, again, you get into the heating and the cooling fighting itself, creating that lack of uniformity. Chilled water too cold, or fresh air distribution out of balance. So when we look at the classic, we recognize that the fresh air enters the fresh air intake damper on the front of the machine and then is distributed the full length of the machine through openings above each one of the 6 overhead fans. If in fact I'm allowing too much fresh air to be distributed in the front of the machine, then you'll see the front of the machine have to cycle heating in order to maintain temperature. And due to the lack of fresh air availability to the rear, then you'll see the rear of the machine that'll essentially overheat. So it's sitting there trying to cool. So the fresh air distribution out of balance is a big key in having a machine that's more consistent with uniform temperatures. We look at that on a graph. Here's an example of that in Maestro, where we recognize that the front cooling was functioning at a rate of 36%, while at the same time the rear heating was functioning at a rate of 37%. And the byproduct of that was a lot of inconsistency in temperature inside of the machine. So this poor uniformity with temperature is definitely going to impact the duration of my hatch window. So uniformity of temperature during incubation, again with multi-stage, we also recognize that condition and position of these overhead fans can also drive that duration. When we look at that, we see a lot of times with the older classics, the condition of the fan blades are relatively poor, oftentimes can be poor. This is an example of a hatchery that had intensified their fogging procedures in the incubator room, and the fog itself was so heavy that it was carrying over into the incubators and finding it collecting itself, leaving the residue on the fan blades. And that sticky residue then allowed any dirt or debris or dust to collect directly on the edge of the blade. That's going to cause a blade to not move as much air, not create enough static, and therefore not have consistent, even airflow or temperature control through the egg pack. In addition to that, position is also a problem. This picture on the right illustrates where a fan blade essentially just wasn't placed or mounted on the shaft to allow the blade to be down in the board opening. So that leading edge of that tip of the blade being up out of the opening causes it to lose static. It can't create enough static, and therefore, again, you lose airflow through the egg pack and creates poor uniformity, inconsistency in temperatures. When we look at what we should see with those fans is you should see a good clean fan board, a good clean fan blade down in that opening. In addition to that, you oftentimes see newer machines, or not newer, but the last couple of decades, with the Vosterman fan package, which allows a quicker, easier wipe down. The thing about the Vosterman is the blade itself on the motor is more of a fixed position, so you don't have to worry about it not being down in the opening like it should. You also see the picture there on the left where this particular fan board has the heating element mounted right on the motor. And so that is that this particular machine has, the ducts have been removed. It's better heating, more uniform, and this machine probably has a split cooling upgrade in it as well. So we recognize that with that, a couple of upgrades being installed really promoted some uniformity, or will promote uniformity in the machine and help impact that duration. So another thing that we see about impact of duration on uniformity is recovery time for warm-up, uniformity of temperature. So when we look at multi-stage, again, recovery time following egg set, when you see this in real time, that's roughly a little over a 3-hour complete warm-up time, and a pretty big temperature drop that occurred as a byproduct of egg set. So you also later, once this machine is completely recovered, you recognize out here in the blue circle where there is a definite percentage difference in the volume of cooling that is occurring in the rear zone versus front zone. And so that within itself also indicates that this machine is out of balance, probably from an air distribution standpoint. So these little pieces that you have the ability to monitor and manage machines in better conditioning will help reduce this duration of your hatch window. So it's always critical to try to spend some time watching your crews set eggs. I know in most classic machines this is happening at night, and a lot of times unsupervised, or maybe done by a hired contract crew. But it's critical to observe this periodically, because doors being left open for long periods of time, things of that nature, can really affect how quick the machine recovers from an egg set, because this will cause a pretty big delay when it comes to your duration. So what else can impact duration? Uniformity of temperature. In single stage incubation, a lot of times we see poor calibration, loose belts, loose fan belts, or dampers out of position. This is one that on the Avita single stage machines, we have a linkage rod that connects all of the fresh air intake and the exhaust dampers together. And a lot of times I find that those are either not calibrated correctly, or they are out of sync, and you'll allow higher volumes of fresh air to dump into certain zones and not others. And that within itself causes the individual zones to operate inconsistently, and that within can create that poor uniformity in temperature. Long warm-up period is something else you also recognize sometimes. We see a lot of our older machines that were installed with strictly electric heating for a warm-up period. Roughly 10 years ago, Chickmaster developed a hot water system that you can install on your machine to allow hot water to assist the warm-up. In general, there's a huge difference in warm-up time and warm-up period. When we look at that, also with a long warm-up period, you may find that you have damaged heating elements. I recognize this periodically when we look at graphing at individual hatcheries. And the thing to always remember is at least a couple of times a year during a routine maintenance check is make sure you force those heating elements to activate and take an amp probe and take a physical amperage reading of those heating elements to determine that they're actually functioning correctly. Also, you'll recognize that hatcheries that run with extremely cold egg room conditions causes those eggs to be very cold, and really cold eggs means that it's just going to take longer to get those up to temperature. And then if you do utilize hot water, just make sure you're operating your hot water at a temperature range adequate enough to bring the machine temperature up as soon as it needs to. So an adequate range for hot water heating is anywhere between 150 degrees Fahrenheit up to about 175 to 180 degrees Fahrenheit. That's usually a really good range. Anything above that, you can get into some too much heat issues, and anything below it, it just extends the warm-up time. So we look at that on a graph. Essentially, that long warm-up period, in this particular case, it's a machine that was electric only. You recognize that the warm-up time from beginning to end is roughly 12 hours and 40 minutes. So in reference, that does give a pretty good representation of what a really slow warm-up period will be. With that slow warm-up, you just have an inconsistency with the uniformity of temperature in the machine itself. So it is critical to try to figure out what causes those delays. When we look at egg pack characteristics, which is something I mentioned earlier for duration, there's a lot of things to keep in mind here. One is flock age. If we look at the difference between, say, a young flock that's 26 or 27 weeks old versus a prime flock versus a old flock, recognizably there will be a difference in hatch window because of flock age. So that's something you need to keep in mind. Farm storage conditions, temperature and sanitation, we recognize that will also impact the duration of your hatch window. We are nearing that time of the year, or we're at that time of the year where seasonal adjustments, especially for the American and Europe, can be in effect because parts of the world are going from summer to winter and other parts of the world are going from winter to summer. And so if you don't seasonally make adjustments to storage egg rooms at the farm, egg truck transportation, and egg room storage at the hatchery to keep those in sync, then oftentimes you'll find that the egg room at the farm may be averaging a much cooler temperature now because there's not as much heat in the environment outside, or vice versa if you're transitioning into summertime. So it's a seasonal correction at this particular time in order to look at those storage conditions. Transfer temperature and rough handling are also something that can definitely impact the duration of your hatch window. And egg age. And when I say egg age, what I mean by that is the duration of time from when the egg was laid or gathered out of the nest at the farm and placed in a cooler, and how long was it before it actually got set into an incubator or placed into incubation. So we know the longer that egg age can be will affect the duration of your hatch window.
So Chad, just quickly on that, because there's a question from one of the attendees. The amount of storage time that you put in for your egg, is that something that we're easily able to quantify? So if you're storing eggs for 2 weeks, say, how would that impact your hatch window?
Yeah, so under normal conditions, every place is a little bit different, but eggs that come into the hatchery have generally been identified either to a specific farm or from a specific source and a date of lay. And so we have to manage the egg room from an inventory perspective as far as keeping up with those and identifying the individual trolleys or rack that they're in, so you can manage your inventory and, you know, realistically keep your average egg age in the egg room the same. So as I start to have an increase in egg volume, or say a decrease in egg setting, if I'm bringing 100,000 eggs in a week and I'm only setting, you know, 80,000, every week I'm going to have an abundance of 20,000 carryover. And so eventually my egg age is going to extend to periods above what we consider optimal. So optimal egg age is going to be in the range of 3 to 5 days from the date of lay. So from the time the hen laid the egg, if I can wait between 3 to 5 days to make that egg set, then I should see no impact on duration of my hatch window, or no impact on hatch window or even hatch. Now, once I exceed the 5 days, then it's a slow decrease as far as a hatch is concerned over a period of a few days. But once I get up to day 8, day 9, day 10, day 11 of storage, then I really start to see a huge increase in, normally it's documented as an early dead. There's enough cell development around the plastidisc that has died off, and therefore when I do make my egg set and I put it into incubation, the embryo doesn't have enough cell growth there to support life of the embryo, and therefore it dies relatively early. And so in general speaking, if you wait till day 12 to make an egg set, that particular eggs, you may lose as much as 5 or 6% in hatch as a byproduct of that long age. And you may add as much as 6 or 8 hours to the duration of your hatch window as a byproduct of it as well.
Perfect. We've got another question which is more on the technical side. It's a customer asking their wet bulb humidity stays at a flat line of 85 degrees during the hatch window. Is that something that you've encountered before?
Yes, and that can be something that is an indicator of many causes. You know, if you don't really ever see an increase in wet bulb, part of it can be a byproduct of a really low hatching flock that is also exposed to a hatcher machine that has a high rate of ventilation. So if I have a hatcher room that is, say, 75 degrees and say 50% relative, but I'm putting a high rate of ventilation through the hatcher machine, that rate of ventilation can cause as the humidity peak occurs, you don't really recognize it on the graph, or you don't really recognize it in the machine because of the rate of airflow through the machine. And that usually has a bigger piece of control on that.
And the next question, why we use an RH sensor in the setters and tend to veer on the wet bulb for the hatchers?
Yeah, so if you'll remember back in the earlier part of the presentation, the real key around wet bulb is the simple fact that it is nothing more than a temperature sensor itself that is completely sealed probe, and by design will handle high pressure hot water wash down. It'll handle the fact that in a hatcher machine you have to wash it down a couple of times a week, and it's really rough on that probe. So if we essentially, bottom line, look at it from that perspective, a probe like that used with a wick and a water bottle, that probe will last a long time in that hatcher machine, where with the presence of an RH sensor, a relative humidity sensor, they're a lot more sensitive. If they get a lot of water on them, it takes them sometimes a couple of days to completely dry out. They're also not very viable. So if they get hit with hot water or they get hit with high pressure water, then they can get damaged pretty quickly. And so that's why we see more consistency with a wet bulb in a hatcher, just simply because of the life expectancy of the probe. So when we talk about egg room conditions and how it can impact the duration, you know, poor airflow can cause temperature variation. And we see that especially in locations that, say, receive eggs in cardboard flats, or receive eggs in where they get stored in a rack system like this. And as you can recognize, these eggs would have to be in this egg room for an extended period of time, probably a couple of days even, before they all are even in temperature. And therefore, if they're not even in temperature when we make our egg set, you've got some eggs that have a much different starting temperature than others. So as a byproduct of it, poor airflow can affect that duration. And a properly set up egg room, you'll see preferably where you've got some separation between racks, and then you've got good airflow through those racks to keep everything consistent and even. When we look at an extended hatch window and what we were referring to with the things that we've talked about on duration, this is an example of having a starting point here and an ending point here, or at least far enough on the back side of the peak that we recognize that we had a duration of 40 hours. So if you do have a Maestro system, or if you are able to document your wet bulb or relative humidity, when you see things that will affect that duration and that uniformity in temperature and the inconsistency in operation of your incubation, commonly this is what you'll find. You'll see this extended time period for your hatch window. And this is what it looks like in your graph. So not a very uniform curve either. So the next portion, we want to talk a little bit about understanding peak, what impacts hatch window and the peak. And so when we look at that, I recognize in this circle here, that's that peak period of what humidity, and that's identifying when I'm at a peak point of chicks pipping out of the shell. And a piece of that is understanding the time difference between when did the peak occur and when am I going to pull those chicks, because the peak is obviously a byproduct of how well we've incubated them, but at the same time, it's also an indicator of, did I hit my set time correctly? Did I start my single stage incubator at the right time? And those things. So let's dive into that a little bit. So when we look at peak, we know a combination of temperature and time are the primary factors that determine when the peak humidity occurs. Our classic multi-stage incubators operate with fixed set points for temperature and humidity, while our Avita single stage incubators follow a profile. So there's a couple of different things that we have to look at in order to manage peak. So a multi-stage incubation requires management of the time that the eggs get set into the machine, while single stage requires managing the correct time to start the incubator. And so there's a distinct difference between those two, although it's very related. Factors that affect both multi and single stage incubation can be breed genetics, flock age, egg age or floor age, and then all of these factors affect our total incubation hours. And that's where the time factor comes in. So if I'm in a existing operating multi-stage hatchery, and I know what my breed is, I know what my flock age is, I look at egg age or floor age, and I'm within an adequate range, I'm either going to add time or take away time for each one of these characteristics, and I'm going to adjust my total incubation hours. I know what time I'm probably going to process my chicks, or what time I'm going to start processing chicks, meaning I'm going to the hatcher machine and I'm going to pull my chicks. So when I add or take away time due to flock age or egg age, then specifically what I'm doing is I'm making an adjustment not to when I pull the chicks, but when I need to set them. What time do I start my single stage incubator, or what time do I put these eggs into the multi-stage incubator? And so that within itself is what allows your egg pack and your developing embryo and hopefully producing a chick. That's what affects its total incubation hours. So I have to take these things into consideration when I set that. So, and that essentially itself is what helps control when this peak occurs. So when we look at peak in this example, you can see that the peak occurred very early, approximately 30 hours prior to pull. You can see that here with this black dot. And this could be an example of someone that maybe started an incubator up too early, or maybe they set the eggs in a classic machine too early. And as a byproduct, it hit peak very early. You can also see that with a high volume of chicks out this early, that it's easy for the coils to get coated with down, causing the chilled water cooling to become ineffective, allowing the hatcher temperature near the end to struggle to maintain temperature. And so this is a good example of having a peak that is occurring way too early in my process. And obviously with temperatures that are out of control near the end, it's difficult to avoid stress or heat stress for the chicks. So we're going to affect our chick quality as a byproduct. When we look at an example here, this is another example of a peak that occurred early, approximately 34 hours before pool. But another thing that's important to recognize on this particular peak is the fact that a 94 wet bulb was achieved, indicator of a very high wet bulb, and it's an indicator of a lack of ventilation or high humidity in a room. You see that here with that peak. It's a good uniform hatch window. Unfortunately, it just happened a little bit too early and it really hit a high peak. So when we talk about that, in essence, on that particular example, another thing that can impact hatch window is obviously ventilation. And so we recognize that environmental conditions for both multi-stage and single stage are important and should operate within a given range to support proper incubation. Ventilation through the incubation equipment plays several important roles. It provides oxygen as a nutrient to the developing embryo, so therefore it is a requirement. It also depletes the CO2, which is a byproduct of oxygen consumption by the embryo. The ventilation also helps remove moisture that is produced by the developing embryos. And then it aids the water cooling system to provide air cooling to the machines. With these critical needs for ventilation, set points are very important. And we recognize that, yes, ventilation can definitely impact our hatch window. We get into that a little bit more detail. The set points for room ventilation should be set specific to the type and size of incubation equipment while keeping the following in mind. The temperature of the air entering the incubation equipment should be cool enough to support machine cooling, but not low enough to cause the machines to heat. So if the room temperature is too hot, then the incubator will average a slightly higher incubation temperature, which in turn will cause the peak to occur slightly earlier. It's obvious if a machine is running warmer, then that will affect when that peak occurs. If the room temperature is too cool, then the machine will average slightly cooler, along with microenvironments in the machine can be a result. The peak can occur later than desired, and the duration of the window can also occur, an extension of that. So both of these things will affect not only chick quality, but also hatch as well. But it would definitely create a spread in your duration. The humidity of the air entering the incubation equipment should be low enough to help manage moisture removal, but high enough to avoid mechanical humidification. And for geographic locations where we're starting to get into wintertime, a lot of hatcheries right now are dealing with drier conditions because it's cooling off. They're fixing mechanical systems inside of the hatchery to make sure the room humidity system is operating. Machine humidification systems are functioning correctly. But again, those are situations where we're trying to avoid having a low humidity condition in a room so we don't have the mechanical humidification that occurs in the machine. So if the room humidity is too high, then the average moisture loss will be lower and will cause an increase in duration because of the lack of moisture loss with the eggs. If the room humidity is too low, then the function of mechanical humidification in the machine can create microenvironments in the machine, causing lower average temperatures, which is a byproduct is going to cause the peak to occur much later. And it will extend the duration of your hatch window because of these microenvironments. So the thing to keep in mind when it comes to humidity and the ventilation in your room is that if we manage the room adequately and we provide the machine with an adequate level of humidity, then we avoid that mechanical function of humidification in the machine. And that's where we get into a situation where the microenvironments are created, especially not so much with single stage, but especially with multi-stage incubators. So the key there is to manage a good humidification system in your room where the ventilation is provided to the incubation equipment, and therefore you avoid it in the machine itself. So when we look at pressure control, it plays another important role. So when we look at ventilation, we always talk about temperature and humidity and room pressure, but we oftentimes forget about plenum pressure, or in some applications, plenum pressure is not an issue. But when we talk about environment, we're always going to discuss temperature, humidity, room pressure, and plenum pressure, because this does play a critical role. You know, both room pressure and exhaust plenum pressure are very critical. So maintaining a room pressure ensures that there is enough fresh air supplied to the room to support the consumption of the incubation equipment. And you can't really emphasize that enough, because if I've got a room that's running low in pressure, then what that tells me is that I have a lack of ventilation. The byproduct is an earlier occurrence of the peak and an increase in the duration of hatch window. Why? Because the machines won't receive enough fresh air. Without fresh air, they're going to have to use more water cooling. You see a lack of oxygen, an increase in CO2, an increase in moisture. All those factors add up and cause a machine to just not run as consistent as it should, because we're not providing adequate environment for the embryo. If the room and plenum pressure is too high, this can cause an increase of ventilation and result in machines that are overventilated. The result is a machine that operates cooler and a lack of humidity along with microenvironments, which again is going to cause that peak to occur later, and again the duration to be extended. So a lot of times we get questions around people want to look at this hatch window and a hatcher machine and ask questions about, why did my peak occur? Why are my chicks coming off too early, or why are my chicks coming off too late? And oftentimes you spend a lot of time trying to make adjustments to your stage program on your hatchers. And a lot of times the key to that is start back in the incubator room first and look at the mechanical condition of all of the equipment, look at the condition of the room itself, and make sure that this ventilation system is not causing the influence. Because you can, if your incubation process, condition of equipment, or your ventilation system in your incubator room is creating these problems in your incubators, then you can play with your stage program and a hatcher machine all day, every day, and never make up the difference. You're not going to improve upon the situation that was created from poor incubation. So start with the beginning and always work back towards the hatchers if you recognize that you do have an issue with your hatch window. And I think that pretty much covers everything I wanted to cover, and leave us enough time to answer a couple of questions.
Perfect timing, Chad. Thank you very much for the content. We do indeed have quite a few questions to follow up with. So the first one I'm going to jump into is, unfortunately, I'm not sure who's asked this question. He's asking about calibration of a multi-stage machine. So when's the best time to do that?
Yeah, the best time to perform the calibration on a classic generally is following a transfer. So wait till you've transferred the oldest embryos out of the machine, and then prior to making your next egg set. And so that way you have a machine that is preferably not hasn't been disrupted, because you're doing it right after a transfer. You've removed your largest embryonic heat source, and so your machine can essentially sit there idle for longer periods of time without having to cycle cooling. And so it is a much more stable environment during that time period. So generally, as soon as you can following transfer, as long as the machine is kind of stabilized. So the key there is you allow transfer to occur, and then you immediately go put your probes in the machine and let them start leveling off, and then come back a couple hours later and take those readings and perform your calibration at that time.
So one of the first webinars that we did covered maintaining the incubators, and we touched on quite a bit of detail on calibration of both single stage and multi-stage equipment during that. So if you do want a little bit more information on that, I recommend you go to chipmaster.com and look up the webinars on demand, and there'll be a little bit more information there for you on that topic. The next question, Tad, is how to reduce yellow navels. We've got a customer here who's seeing a higher incidence of yellow navels on their multi-stage machines with an ISIS control compared to their single stage machines.
Okay, so in that situation, it could be associated with two things. One, the first thing I challenge you to do is to become more aware of what your hatch window looks like. When does your peak occur, and what is the duration of your hatch window? And understanding those two things that we covered today will probably lead you in a direction of being able to resolve that issue. So if we're talking about unhealed navels as a byproduct of my peak occurring, say my peak doesn't occur until 10 p.m. at night, and yet I'm pulling the chicks at 6 a.m. Well, I only have an 8-hour duration from peak to pull. And if you understand when your peak is occurring, then that's going to give you a direct indicator that at pull you are going to see chicks that we refer to as either green with unhealed navels, or chicks that just aren't ready to be pulled yet because they haven't had enough time to completely cure their navel and become ready to be processed and ready to be placed. So it's a great question, but it goes right back to the topics we've covered here. Identify when your peak occurs and identify the duration of your hatch window. And your goal is to get control of both of those, and most of your issues, especially around chick quality and navel issues, you'll start to see them go away.
So the last question that I've got here, Chad, is customers asking if there's a difference between Ross eggs and cob eggs when it comes to the hatch window and what you can expect to see. And it's worth pointing out at this moment that the next webinar that we're going to be putting on in November, we're actually going to have some special guest panelists from both cob and Avigen who are going to go into far more detail on exactly the expectations of their eggs in relation to Chickmaster incubators. But I'll hand over to Chad now just to answer the question briefly.
Yeah, and it's a wonderful question, and that's exactly why we're scheduled to have that webinar in a month from now, or next month's webinar, because the realistic value of the fact that when you look at Avigen and say cob, for instance, or in references of geographically, some countries still refer to Avigen maybe as a Ross. Each breed, whether it's cob or Avigen, both have what's recognizably a bird that by design has better yield and better performance for a specific weight range. So in some cases, maybe your complex or your company determines that their product requirement says we need to kill a smaller bird, or we're only going to grow them to a very low weight. Then that gears you in a direction to go with a specific type of genetic line from either one of the breeders. And the same goes if your choice is to provide a product from a much larger bird. And we do recognize that from dealing with customers over in 100 different country locations, and the different breeds and the different genetics that go into those, we've recognized many times that at the end of the day, you can be successful with all of those at the same temperature if you give them enough time. But with that, there is a difference with certain breeds. Some will, when we look at single stage incubation, some require a little bit higher temperature in the beginning, while others can't handle those higher temperatures in the beginning. And same goes for multi-stage. Because of the requirement for warmer temperature, I'll see a multi-stage hatchery running a specific type of breed, and they may run their incubators at a set point of 99.9 in an attempt to get that embryo further along. Unfortunately, when they run the multi-stage that high, they'll witness some eggshell surface temperatures prior to transfer that may exceed what is considered ideal in order to avoid heat stress prior to transfer. So to answer the question simply, yes, there is a difference. It can be as a matter of just a couple of tenths of a degree in the beginning of incubation, but the key is still managing eggshell surface temp prior to transfer, and then in the hatcher understanding where this peak and your hatch window are occurring at. But we really look forward to that webinar that we're going to have here in a month from now with Cobb and Avigen both on that webinar to discuss this in more detail.
Perfect. So the next question is a two-parter. I'm going to combine questions from two separate customers here. First part is, does Spides have an impact on the duration of that hatch window and the peak of the hatch window? And the follow-up being, if you wanted to do Spides, what's the best way, and is it possible to do that in a multi-stage machine?
Okay, so just so everybody here is on the same page, when we reference to Spides, we're talking about an acronym for short periods of incubation during egg storage. And so it's a practice that's been in place for many years. Spides is an acronym or a definition that Avigen specifically designated to a process, and I know for a fact that that their team of people have put a tremendous amount of effort into getting the details of how to do it, when to do it, what flock ages are best and more susceptible, what floor age. So there's a lot to it. And I do have to say that whether you're a multi-stage or a single stage, it's really irrelevant. If I'm going to have egg age in storage, if those eggs are going to be in storage for an extended period of time, there's a lot of data that supports improvements in hatch and managing peak and duration of your hatch window if you implement a good Spides program. Can it be done in a multi-stage? If you have an empty classic machine and the ability to essentially go in and make a partial set in that machine, don't fill it up completely, just go in and make a partial set, then you still have to manage monitoring the internal egg temperature of those eggs, because ideally you want to get them from egg storage temperature up to an incubation temperature and then back down again, and you want to get all of that accomplished in a period of about 8 to 9 hours, and that is that ideal range. And so you're not going to be able to do that if you overfill a classic machine. If you do a partial set in a classic machine, the other thing that can be accomplished, we sell a machine today that we call an Encore. There are other machines available in the industry that you put in your egg room, and essentially it does have a much higher heating capacity and a larger volume of egg storage capacity, and it keeps you from rolling eggs from the egg room all the way off to an incubator somewhere. But you can simply run the eggs into this machine in the egg room, and once the process is over, you simply remove them back out of there. But I would emphasize, if you're more curious about the real details and exactly how to follow that process, if your primary breed source is Avigen, please contact that breed source company, or if it's Cobb, please contact them to discuss those details, because there's a lot to it. It's not a simple matter of saying, hey, I'm going to set these eggs on day 12, so on day 8 I'm going to go run them through a Spides process, and that's going to cure the world. So there's a lot of detail to it.
Perfect, thank you very much. So the last question we have here, and I know you've touched on ventilation quite a bit, on the importance of getting the correct ventilation amount through your machines, but there's a customer here after specific recommendations for the plenum pressures for hatches.
Okay, so when we look at our specification sheet for hatchers, and when we talk about hatchers, Master hatchers, we have hatcher machines that primarily range from what we refer to as a Model 90 VFP, which has a vertical fan package, or we call that a CVH hatcher. Generally holds 90 to 96 baskets. Very common in a multi-stage type hatchery. Those machines, if you look at the internal makeup of the machine, the vertical fans are essentially drawing air into the hatcher, because the fresh air intake of the machine is essentially in the negative suction side of the fan. So we refer to that hatcher as a naturally self-ventilating hatcher machine. You don't have to have a plenum in order to get that machine to actually, you turn it on and it will draw air through that machine. So it's self-ventilating. So plenum pressures, when we refer to that with that particular type of machine, we always make sure that the plenum is referenced back to the room, and therefore we're controlling differential across the machine. And with that particular machine, if my hatcher room is a 0.015 positive to the atmosphere, then it's very common to have a hatcher plenum that in reference to the room would be set at, say, a negative 0.015 at transfer. And then you may progressively take that slightly higher as you get closer to the pool of the chicks, and depending on the room temperature, room humidity, and how well that's maintained, you may need to take that plenum maybe as negative as a negative 0.025 or a negative 0.03. And all that does is influence a little bit higher rate of airflow through the hatcher when you near the end of that hatch cycle, and that helps with cooling of the chicks. In the other style of machines, which is such as our Vita style, or the ones that have the paddle fan in the middle, those machines are not referenced as a self-ventilating machine. You actually have to create differential across that machine to get airflow to go through that. In addition, you also have an auxiliary blower that you activate at a certain time of the incubation cycle or hatch cycle, so it helps with air as well. And again, differential pressure is something that you make adjustments to, and you physically want to put yourself in a situation where you go in that plenum and you actually measure the airflow coming out of the hatcher machine, and that will adjust your plenum in order to guarantee that you've got adequate airflow through there. You should be in that range of 5, 6, 7 CFM per thousand with 100% damper opening and no blower. But then as you lead up to pool with a blower active, you may be in a range of 10 to 12 CFM per thousand. So it's pretty simple to get the plenum, take that measurement, adjust your plenum. And with that particular machine, you may be anywhere from a 0.08 all the way up to a 0.15 in pressure in order to have adequate airflow.
Perfect. Thank you very much, Chad. So that exhausts our questions for today. Thank you very much again for joining us this week, and we'll see you at the next webinar.